Okay, in this video, we're gonna focus on the factors of partial fraction. Of course, earlier before now, I told us that for you to solve any question on partial fraction, there are conditions you need to apply. The first one is to know if the partial fraction is either a proper partial fraction or an improper partial fraction. So if you verify that that partial fraction is a proper partial fraction, so we use these particular factors to solve that. And in our next video, we are going to consider the factors we use to solve improper partial fraction. All you just have to do here is to hit the subscribe button to get the full series on partial fraction, okay? Now let's know the factors of partial fraction. The first factor here is linear factor. Please take note. The first factor here is linear factor. So when you say factor said to be linear, okay? Now before we consider the linear factor, let's know when an expression is linear. If I have this to the class 2s plus 3, we call this linear expression, right? So why? Because the power of s is raised to the power of 1 here. Please take note. So if I have something like this, 1 over as plus b into cs plus d. We call this, now listen to me, we call this expression here linear factor. Now, for you to identify the factors, listen to me carefully. For you to identify the factors in partial fraction, we always focus on the denominator expression. For you to identify the factors in partial fraction, we always do that at the denominator part. Please take note. Okay. Now, this is the denominator part here. This expression here is linear, so we call it linear factor. Now, for all linear factors, we have the solutions we use for all linear factors. So if I have this to be a linear factor, that is, this is a linear factor, as plus b into cs plus d. So the solution for all linear factor is that you assign each of the factor here, this factor here, you assign a constant letter to it. The same thing here, each of this factor here, you assign a constant letter to it. Now let's choose the first letter, which is a. We'll say a over as plus b plus, assign a constant letter to this. This is going to be b over cs plus d. Please take note. So this is how we evaluate all linear factor. Whenever I say linear factor, the solution to that is going to be assign a constant letter to it. Okay, so let's consider the next one, the next factor, repeated linear. The next factor, repeated linear. 2 repeated linear factor. Now, of course, this particular question here is on linear, okay? But this one here is repeated. So when do we say that a linear factor is repeated? If I have something like this class, if I have this to be this 1 over, this one here can stand as anything. Please take notes. We are going to solve the question here to understand properly, okay? So if I have this to be 1 over as plus b raised to the power of 3, it means that this particular linear expression is repeated into 3. And for every linear, to find the solution of for every linear, you assign one constant value letter to it. So assign one constant letter to it. This is going to be a over as plus b plus, assign another one. Remember, you are going to repeat this into 3 parts. So this will be b over as plus b plus c over as plus b. Please take note of this. So the next factor we are going to consider here, class, is factorizable quadratic factor. Factorizable quadratic factor. So class, if I have the next one, factorizable but the next factor we are going to consider here is factorizable quadratic factor. So if I have this to be 2s plus 3, we said this is linear. But if I have this to be, class, 2s squared plus 4s plus 3, we say this is quadratic. Please take note. When the power of s is raised to power of 2, we say it's quadratic. So if I have something like this, class, 1 over as squared plus bs plus c. Class, whenever you have a factor that consists of only quadratic at the denominator, please listen to me carefully to understand what I'm saying, okay? Whenever you have a partial fraction that consists of quadratic at the denominator, only quadratic at the denominator, so at that point we call that particular factor factorizable quadratic. But if a factor, other factors are attached to the quadratic, it will be non-factorizable quadratic. But let me first of all explain this before we explain the next one, okay? Now, if you look into this question here, class, what is here is quadratic only at the denominator. So since it's only quadratic at the denominator here, it will be called factorizable quadratic factor. Now, at that point, you can factorize this particular, using factorization method, you can factorize this particular expression to look like this, 1 over s plus b into cs plus d. So whenever you have a factor or a denominator in a partial fraction, and in that denominator we only have quadratic, it means that that particular quadratic will be factorizable. And when you factorize that factor, it will form this particular factor, which is a linear factor. And we all know that for all linear factor, if I have something like this, that is from this 1 over that is from this 1 over as plus b into cs plus d. The solution will be a over as plus b plus b over cs plus d. Please take note. So for every linear factor, we assign a constant letter to it. Please take note. So let's take the last one here, that is repeated quadratic factor. Sorry, let's take the next one here, number 4. Let's take number 4, non-factorizable quadratic factor. Non-factorizable quadratic factor. Now, class, how do we identify non-factorizable quadratic factor? Class, whenever you have a quadratic factor at the denominator and there is other factors attached to it, or yes, attached to it, we call it non-factorizable quadratic factor. So if you have something like this, class, you have 1 over as plus b into as squared plus bs plus c. Class, if you look into this, listen to me class, if you look into this part here is quadratic, this part here is linear. So class, this how to understand, or this how to know when a quadratic factor is non-factorizable or is factorizable. Whenever you have a partial fraction and the factor or the denominator part is only quadratic, it means that that particular quadratic can be factorizable, just like this one here, class. And when you factorize that, it's going to look like this, guys, here. But whenever you have a factor that is quadratic factor and there is other factor attached to it, either linear or repeated linear, depending, okay? Now, if you look at this one here, we have linear attached to quadratic. So it means that this particular quadratic here will not be factorizable. This particular quadratic here will not be factorizable. So the question now is, what is going to be the solution to this? The solution to this will be equal to, let's solve let's apply the method of a linear. The linear is always attach a constant to it, a constant letter to it. So this will be a over as plus b plus y. In terms of quadratic, that is non-factorizable quadratic factor, we say the constant letter will be bs plus c over as squared plus bs plus c. Okay, now let's look into the last one before we solve the question here. Okay, the last one here, 5 repeated quadratic factor. So if we have an expression like this, 1 over as squared plus bs plus c all squared. Of course, we know that this is a quadratic. What is inside here is quadratic and is being repeated by 2. That is raised power of 2 here. Please take note. So how do we solve this? Remember, we have an approach or the solution to solve all quadratic factor. So that if I have a factor to be quadratic, that is 1 over as squared plus bs plus c all squared. So I will have this to be as plus b. For the first quadratic will be as squared plus bs plus c plus, for the second quadratic will be cs plus d. I'm using cs plus d because we have already used this letter a, letter b. So the next letter to use is c and d. There's other one here. The next one to use will be e and f. Please take notes. Over as squared plus bs plus c. Please take note. So this is how we express the solution to each of the factors. So let's solve question 1 here for us to understand this properly. Question 1, please. Okay, class, let's solve this question here. Let's say resolve 3s plus 2 over s minus 1 into s plus 5 into partial fraction. Of course, for you to solve any partial fractions, you have to consider the two conditions. Okay, the first one here is to know if it is proper or improper. So class, let's know that from the power. The highest power at the numerator is 1. The highest power at denominator is 2. If you times this with this one, you have 2. So this is proper. And for all proper partial fractions, we have factors. Okay, the next is to consider the factor. So how do we consider the factor? We check the denominator part. So this is linear, this is linear. Please take note. And there's a solution to all linear And this is what you have to do. That is, we have this to be class solution first. We multiply both sides by s minus. Listen to me carefully, class. Please listen to me carefully. Multiply both sides by s minus 1 and s plus 5. So this will be cancelled. This will be cancelled, okay? So do the same thing at the right hand side. We have this to be s minus 1 times s plus 5 of a over s minus 1. So this guy here, we cancel this, okay? So the same thing here, s minus 1 into s plus 5 multiplied by b over s plus 5. So this guy here will cancel this. So I'll be left with class. I'll be left with 3s plus 2 equal to s plus 5 of a plus s minus 1 of b. So in mathematics, whenever you have brackets, to move to the next step, you open the bracket. So let's open that bracket here. So when you open this bracket here, class, we'll have something like this. 3s plus 2 is equal to as plus 5a plus bs minus b. So class, let's take light terms here. Let's take light terms. When you take light terms here, that means we have something like this. 3s plus 2 is equal to as plus bs plus 5a minus b. So after like terms, we compare both the left hand side and the right hand side. So in partial fraction, after taking like terms, we compare this part here and compare this part here. Please take note. So let's compare the right hand side and the left hand side. So when you compare this, in terms of their letters, at the right hand side we have ESC. So compare all the ESC at the right hand side, all the ESC. Compare all the ESC at the right hand side. That means we have this to be 3 equal to, compare all the S at the, sorry, compare all the S at the left hand side. We have 3. That is this 3 here, the coefficient of S here. Now compare all the S at the right hand side. We have A plus B. We'll call this one equation 1. Now the next one here is the part that does not have any letter. So we'll call that part constant part. Constants. Now compare all the part that does not have any letter, that is 2 at the left hand side. At the right hand side is 5a minus b. We call that particular equation equation 2. Please take note. So we have equation 1 and equation 2, and we are asked to solve for the unknown. The unknown is a and b. Please take note. So whenever you have equation 1 and equation 2, you are asked to solve for unknown. We use simultaneous equation. So let's use simultaneous here. To use simultaneous here, remember, we have this to be the same thing as a plus b equal to 3 and b, sorry, 5a minus b equal to 2. So I'll do a line like this. I want to use elimination method. So if you look into letter a and a here, there's nothing to eliminate because they are not the same coefficient. But if you look into letter b and b here, they are of the same coefficient except the sign. So what is the sign am I going to put here to eliminate b and minus b? The sign to put here is plus. So if I have b plus minus b will give us 0. So let's try to solve this. So since I have eliminated this guy here using elimination method, let's add up 5a, or if you are starting from the bottom to the top, you also start from the bottom to the top at the right hand side. Please take note. Anything you apply at the left hand side is the same procedure you also apply at the right hand side. So since I'm starting from a plus 5a, so at the right hand side here I will start from 3 plus 2. So this is going to be a plus 5a will give us 6a is equal to 3 plus 2 give us 5. So let's make a the subject. I will divide both sides by 6. Divide here by 6. Divide here by 6. That means a is equal to 5 over 6. So how do we get the next letter? To get the next letter, we replace the value of a into any equation, either equation 1 and equation 2. You still get the same stuff here. Please take note. So replacing that into equation 1, that is very simple. Okay. So we say putting a equal to 5 over 6 into equation 1 or equation 2, depending on the one you like. So let me use equation 1. That is a plus b is equal to 3. This is what equation 1 is. So in this equation 1 here, anywhere I see a, I will impute 5 over 6. When you do that, we have something like this, class. We have 5 over 6 plus b is equal to 3. Of course, from here, our intention is to make b the subject. That is the letter the subject. Making b the subject, b will be equal to class 3 minus 5 over 6. Class, whenever you have something like this, this is 3 minus 5 over 6, of course. This part here is fraction, and we can also make this part here to be fraction. That is saying over 1. Please take note. So solving this fraction and this fraction here is very simple. There's a shortcut to solve this. If I have 1 over 2 plus 1 over 3, The shortcut to solve this without looking for LCM is to multiply this right denominator to the opposite, and this left denominator to the opposite, and you multiply both denominator. So I'll have this to be 3. If there is plus, you put plus here. If there's minus, you put minus, depending on the sign here. Please take note. 2 times 1 will give us 2. Multiply both denominator will be 6. Please take note. So apply the same format here. I will have this to be this times this will give us 18 minus 5 over 6. So this is going to be equal to 13 over 6. So our B is 13 over 6. But remember, we are asked to resolve the partial fraction. We are not asked to find A and B. If you are asked to find A and B, that means our A is equal to 5 over 6. Our B is equal to 13 over 6. But since we are asked to resolve the partial fraction, it means that we have to replace A and B into the fraction. Please take note. So how do we do that? Remember this. Remember that we said that 3s plus 2 over s minus 1 into s plus 5 is equal to A over s minus 1 plus B over s plus 5. So anywhere I see A here, I will replace that as 5 over 6. Anywhere I see B here, I will replace that as 13 over 6. So when you do that, we have this to be 5 over 6 over s minus 1 plus 13 over 6 over s plus 5. Please take notes. So when you simplify this class, now let's simplify this here. If I have something like this class, let me just explain this to us before we simplify, okay? Let me just explain this to us before we simplify. If I have this to be 5 over 6 over s minus 1, this is the same thing as 5 over 6 divide by s minus 1, something like this. Now, over 1. So if you apply board mass from here, if you apply board mass, the right part will be inverted. So this is going to be something like this. If you apply board mass, it will be 5 over 6 times 1 over s minus 1. Please take note. So 5 times this will give us 5. 6 times this will give us this part here. So when you evaluate something like this, when you evaluate this perfectly, okay, so when you evaluate this will be equal to class 5, which is the one at numerator, will be at the top, while the one at denominator will come down, which is going to be over 6 into s minus 1. Okay, I'm putting bracket here because this 6 is affecting both s and minus 1. Plus, do the same thing here. The one at the top will be at the top, while denominator will come down, which is 6 into s plus 5. Okay, now this is how we evaluate partial fraction. So the next question, the next factor will be repeated linear factor. So if I'm given something like this, if I'm asked to resolve something like this, s raised to the power of 3 minus 1 over s minus 2 raised to the power of 3. Now, this is the next question we are going to treat. All you have to do to get or to understand this perfectly is to hit the subscribe button. Thank you.